Hello students. So let's discuss the instructions, the instruction classification. This is using the type of instruction. Okay. So in that we have a data transfer instructions. We can classify the instructions into different uh, types depending on what the instructions will perform, what is the operation performed by those instructions. So in that case we have data transfer instructions, arithmetic instructions, logical instructions, branch instructions, and so on. So in this video let's discuss data transfer instructions. Okay, so we know already, we have seen move. First data transfer instruction we can say is move. Again, in data transfer instructions, the data transfer can be between the registers or immediate data to a register, or between the memory and a register. So let's see that. Move B to A. So here this is the transfer between the two registers which are already present, which are present in the processor, inside the processor. Okay, so with the execution of this instruction, the contents of B register will be copied to A accumulator. Okay, so like this we have different combinations of registers like B to C, move B to D, B to E, B to H, B to L, so on. And again we have like move A to B, A to C. Okay, so we have so many registers, like 6 general purpose registers and accumulator. So all the combinations you'll have these simple register to register data transfer instructions. Okay, so this is one set of data transfer instructions. Then comes the immediate, like data to a register. The data will be present in the instruction. Okay, so that is move immediate. This immediate shows that the data is present in the instruction itself. So register and 8-bit data. So what all we can have here? Move immediate 20H to A. This 8-bit data to A. With the execution of this instruction, 20H will be loaded to um, accumulator. In the same way with all registers will have this. Like I can say 20H to B register, to C register, D register, all the registers. Okay, so this is immediate addressing, where 8-bit data is moved to or copied to transferred to the registers present in the processor. Okay, then we have a 16-bit immediate addressing, like load immediate. Okay, here X indicates that the register pair is used in this particular instruction. So load immediate B with 16-bit data. Okay, with the execution of here load immediate, X indicates here that here not a single register B but the register pair BC is used, because this is a 16-bit data. You cannot load 16-bit data to single register, 8-bit register. Okay, so the 16-bit data is loaded to B and C as a pair. Okay, so if suppose I say load immediate 4000H to B. So after the execution of this instruction, we see that in B register you'll have 40H and in C register you'll have 00H. Okay, so this is immediate addressing using the register pair and 16-bit data. In the same way we can have load H with 4000H. So here this 4000H, that means in H will have 40 and L register will be loaded with 00H. Okay, one of the special character of this, or property of this H register is, HL pair is, HL pair is used as a memory point. Okay, so if we have an instruction like move M to A, M2 register, A or B or C or D. Okay, so here move M to A. Here M means it is the memory location. Where is the address of that memory location? It is implied in this instruction that the address of this memory location will be in HL register. So it will take the address from the HL register. From that memory location, the data is transferred to accumulator. Okay, let us suppose if I use these two instructions one after the other. So before using this register, I need to load HL register with the memory address. So with the execution of this instruction, so in the memory at 4000 H, some data will be there. Let us suppose 96 is there in this location. I have loaded this, the pointer I used, the HL pair as the pointer to this memory location, because I loaded this address to H and L. Now I use the instruction move M to A. Here M indicates the memory location whose address is there in HL register pair. With the execution of this instruction, now accumulator will have 96H after the execution. If I write here move M to B, then B register will be loaded with this 96H. The reverse is also there, like I can say move A to M. When I say A to M, again whatever data is there, contents of this accumulator register will be loaded to a memory location whose address is there in HL pair. Move B to M. Okay, so these are one set of instructions. Then we have some special memory transfer instructions. Load accumulator with register pair. Okay, here I can write, let us suppose if I write LDAX, load accumulator with B. So here it indicates that BC is holding an address. Here what is done is from B to A, from memory to accumulator. The data transfer is from memory to accumulator. Where is the memory address? The memory address is there in BC register pair. BC is holding an address. From that address location, the contents of that address location will be loaded to accumulator. Then we have immediate addressing also is there in this case. Load accumulator with 16-bit. That means in this instruction, I'll give the address of the memory location in the instruction itself. If I say LDA 4000H, what is this? This is the address. So from this address location, the data present in this address location is loaded to accumulator. Okay, so the reverse of this is also there. Stacks. Store accumulator register pair. Here it can be B or C or H. Here also. So stacks, store accumulator. This is from the processor to the memory. In this case, loading case, it is from the memory to processor. The data is transferred from the memory to the processor. Processor accumulator is in the processor. Here it is from the processor to the memory location. So here if I say store accumulator B, so the accumulator contents whatever is there in accumulator, that will be moved to or copied to BC pair is holding an memory location. BC pair is holding an address of a memory location. So to that memory location, the accumulator contents will be transferred. So that is stacks. Store accumulator. This is also same, but here the address is given in the instruction itself. In the instruction, if I say 4000H, here accumulator contents will be transferred to the memory location whose address is 4000H. Okay, so this is how these are one set of data transfer instruction. Then we'll see some more instructions. Then we have LHLD. LHLD 16-bit. This is load H and L registers direct. The full form is load H and L registers using direct addressing. Here 16-bit is the address. I can write it as LHLD 4000H. So here this is the address. Here what? This is direct addressing. That means in 4000, I'll say 4000 location contains copied to L register, and 4001 location contents will be copied to H register. Okay, so here with this instruction, here you are specifying from which location the contents to be transferred to H and L register. So this is actually 16-bit transfer. Till now whatever the instructions we have seen, those are all, that data transfer is only 8-bit. Okay, here it is 16-bit transfer from the memory to loaded to the H and L. So in the memory, like if this is 4000 and this is 4001 location, you have some data here. After the execution of this instruction, you will have in H register and L register 23 in L register and 43 in H register. Low address byte in low register and high address byte in high register. It is this way. Okay, so this is what happens with the execution of LHLD instruction. In the same way you have SHLD 16-bit. This is reverse of this loading. This is from HL register to 16-bit. So HL register, let us suppose H and L register is holding data 96, and here if the address specified is some 3000H. After the execution of this instruction, what we see is in 3000H location you will find 96H, and 3001 location you will find this 43H. Okay, so H and L data is transferred to the memory locations, two consecutive memory locations whose address is specified in the instruction. So these two are the 16 bit. 16 bits are transferred between the memory and the processor. Then we have in and out. So these are memory transfer between the input output devices. Input output devices can be connected, IO devices can be connected to the processor, isn't it? We need at least one input device and one output device to use the processor. Without those devices, you cannot make the processor perform any operation. Input device, output device, and memory and the processor, these are the basic things you must have in the system. Okay, so here in 8 bit. So here 8 bits is the port address, the address where you connect this input device, you call it as the port address. Okay, so if I say in 8 bit, so from the input port, ATH is the address. From this address, the processor will read the data and the data will go to accumulator. Read the data to accumulator. In the same way, in case of output device, out 8 bit port address. This is the output device address. So with the execution of this instruction, whatever is there in accumulator, that will be sent to output device. What is the address of this output device? That is specified in the instruction. So these are the data transfer instructions. So in the next video, let's see arithmetic instructions.